Hello, everyone, and welcome to today's AISC student webinar entitled Winning Writing Strategies for Students, SSBC Supplemental Competition and Beyond. Today is October 1st, 2020. My name is Christy Sattler, and I am the Senior Engineer for University Relations at AISC, and I'm also part of the planning team for the Student Steel Bridge Competition. I will be moderating today's session. I have a few brief announcements before we get things underway. First, you'll notice that there is a Q&A window on your console. Please use that window if you have any questions for our speakers. We will answer questions at the end of the presentation. You can also use that Q&A window if you have any technical difficulties. We will do our best to help you with those issues. If you have issues with your audio at any time, we do recommend just refreshing your browser, as that often solves the problem. Along the bottom of your screen, you will notice a series of buttons. The button that looks like a piece of notebook paper contains the resources. In there, you will find a PDF of the slides for today's presentation. There is also a link that will take you directly to the SSBC website. And finally, I do need to let you know for legal reasons that today's presentation is being recorded. Here is an overview of what we will cover today. First, we will start with a brief overview of the new supplemental competition, including the 4 categories of competition. Then we will turn things over to our 3 speakers who will share their own strategies for preparing engineering reports. Next, we'll discuss AISC's new partnership with NCSEA, which is the National Council of Structural Engineers Association, and how you can take advantage of that. We will finish up with a panel discussion and a Q&A session with our 3 speakers. As a reminder, you can submit your questions using the Q&A window at any time during the presentation. Our speakers are excited to share their decades of experience with preparing engineering reports. However, they are not part of the SSBC Rules Committee, so they will not be able to answer any specific questions regarding the competition rules. Okay, so what exactly is the supplemental competition? Well, this is a brand new competition format that AISC launched this year to provide additional opportunities during the ongoing pandemic. Recognizing that it may be difficult for teams to gather to fabricate a bridge and travel to an in-person event, the supplemental competition is 100% virtual. The bridge geometry and site plan is the same as the main competition, and you will see that the supplemental competition rules refer back to the main rules. Similar to the main competition, there are 2 levels of competition, the regional events, and then a select group will qualify for a national final. I want to remind you and your team that you will need to pre-register by Friday, October 30th. Your team's faculty advisor can visit aisc.org/SSBC to fill out the pre-registration form. Both sets of rules for the main competition and the supplemental competition are located on the same page at the aisc.org/SSBC website. This is also where you will find the official clarifications. If you do have a question for the Rules Committee, you will find a link on the right-hand side of the page to submit your question. The Rules Committee will provide a response that will be added to the clarifications for other teams to see as well. So as I mentioned before, the supplemental competition is a 100% virtual event, and teams are challenged to design a scale model steel bridge. You will be asked to develop a portfolio that will be judged by industry professionals, steel construction specialists, and members of academia. That portfolio will include a written report as well as a video, and together, those should show how your team's bridge design meets the client specifications and optimizes performance and economy. There are 4 separate judging categories: the design portion, analysis portion, construction sequencing portion, and a video. We will take a brief look at these 4 categories, but I encourage you to read the rules in detail for all of the requirements. First, the design of the bridge focuses on the objectives and constraints that are associated with the bridge's geometry, fabrication, and construction. A good design efficiently uses material, considers ease of fabrication and construction, and allows the structure to function properly under the expected loads. When reviewing potential options, the aesthetics and innovation can also play a significant role. The design portion includes a description of the final design process and the principles used to select the final configuration. It should include things like the advantages and disadvantages of the selected overall design, an overview of any innovative features, and a discussion of the aesthetics appeal. Structural analysis methods and software packages allow engineers and SSBC teams to predict the performance of their structures. However, in order for the analysis results to be useful, several engineering skills are required. These include proper modeling techniques and assumptions, proper demands, consideration of things like geometric imperfections, structural stability, and loading sequence, and the ability to verify the results generated by a computer analysis. So the analysis portion requires you to describe the analysis methods that you used, discuss the perceived limitations of the analysis, and provide a summary of the results. Thinking about how a structure is constructed can be just as important as making sure that it can carry the loads. As designers develop their final design, they should consider the erection process and how things are put together. The construction sequencing portion should contain a description of the final construction sequence, as well as a description of the methods used to decide that final sequence. And finally, the results of your final design, analysis, and construction sequence won't go very far unless you can communicate that information to your client. It is really important to be able to convey that final design to a client in such a way that is professional, concise, and informative so that they can understand and accept the work. The video portion of the supplemental competition challenges you to create a brief video that is directed toward the owner who will be selecting the final bridge. We will not discuss the video in detail during today's webinar. So at this point, I'm going to turn things over to our three guest speakers who will share their own strategies when it comes to assembling engineering reports. And we'll start first with design. So at this point, I'd like to introduce Jason Stiff. He obtained a PhD in structural engineering from the University of Texas at Austin after receiving both Masters of Civil Engineering and Business Administration degrees from the University of Kentucky. He is a bridge technical manager working for Michael Baker International in their Louisville, Kentucky office. To date, he has made significant contributions to several major bridge projects touching every stage of a bridge's life cycle, including the design of two separate 550-foot basket-handled network tied arches over Kentucky Lake and Lake Barkley. He has worked with the AASHTO NSBA collaboration, where he is the vice chair of the Steel Bridge Erection Task Group. Jason has assisted in numerous complex, long-span fracture-critical inspections, including more than a half dozen Ohio River bridges, and he has also been involved professionally with the development of a national standard for steel bridge design and analysis. He was awarded the 2016 National Society of Professional Engineering Young Engineer of the Year Award. Jason lives in Rhineyville, Kentucky, with his wife Samantha and their 6 children. So thank you for being here, Jason.
Thank you, Christy. Appreciate the introduction there. And want to get right on into it here. So let's talk about designing bridges. And generally, let's talk about design in general. So for those of you who may be starting into this, design is quite simple. And it really doesn't matter whether it's a bridge design, highway, water, electrical, mechanical, anything. The simplest equation when it gets down to design, and really the only thing that gets down to design is this very simple equation. The capacity has to be greater than the demands. So we're going to look at this equation of capacity and demands, but it really boils down to that simple. No matter what you do in engineering and in design, it has to come down to this very simple equation, and we'll write it in complicated ways and look at it different ways, but it basically boils down to this. The capacity of any member has to be greater than the demands that we're going to put on that member in order for it to be safe for the public. Before I get started, I do want to start a little bit with a couple of bridge terms to make sure everybody is aware of this and that hopefully I don't use a term that you're unfamiliar with. For most bridges, we will have an abutment, which is the substructure of the portion supporting the bridge at the beginning and end as it attaches to your roadway. Underneath of the bridge supporting it intermediately may be piers, and that supports the bridge intermediately through multiple spans. The girders are the units that span between your piers or between an abutment and a pier. The concrete deck is what you drive on. And then along the side of the road to kind of keep you in there, there may be barriers, also called parapets. I just want to make sure we have those terminologies in case it's used now or in your future. You've hopefully have seen that terminology. So let's get back to designing a bridge. For most of our highway designs and highway bridges, the things that matter are trucks. Trucks load up a bridge, and their weight has to be supported over top of a river, over top of another road, a railroad, or whatever obstacle we're trying to cross. And the cars in general are light and are relatively insignificant, and so we can completely focus on the design of a truck typically. For the steel bridge competition, they made it a little bit easier. You have, a set steel weight and load that have to be handled. But no matter how you do it, you still have to get the loads from the point of application to the support. And so that's called a load path, and you have to understand the load path of your bridge in order to design it. So for our normal steel bridge design, we would design the deck in order to support the truck wheel weights. And the deck spans between the girders. So you design the deck to support the truck. Then you go in and say, all right, I know the weight of my trucks and my deck. I need to design the girders. And I'm going to size the girders in order to support the weight of the truck and the deck above them. Then you have to go to the piers, and the piers span and support the girders, which span between them. And so the piers, you have to design those to support the truck and the deck and the girders and then their weight. And finally, that has to get down to your foundations, and you design the foundations to support the truck, the deck, the girders, and the piers. So there's a load path that you follow from the point of application of the load through your structure to the point at which it hits your supports. And then, of course, finally, you have to make sure it's built correctly. But this idea of load path is critical as you try to think through your structure and how am I going to support that load most efficiently and get it from its application to the supports. So back to this equation, an equation of capacity versus demand. So for every member, as you go through this load path, we got to ensure that each the capacity of that member is greater than the demands placed on that member by the loads. So capacity, how do we get it? Typically and historically, we break it and then predict it, right? So we may go into a laboratory like you see in this picture here of a truss that's getting loads applied to it, and they're trying to, in this instance, determine when this truss is going to buckle. Buckling is a form of failure, which we'll talk about. But if I can write a mathematical equation or some sort of model, I can predict that in the future, and that's what we put into our code equation. So for capacity, we break it and try to predict it. The demand side of the equation is generally done by structural analysis, computational modeling, and that sort of thing. That section is what Christine is going to talk about here right after me, but it follows along with it. It's the two parts of the same coin, right? So you have to know your capacities, you have to know your demands. So when I'm talking about capacity and design, I'm going to speak more towards that design side and the capacity side of the equation, while Christina is going to be talking about the demands that you apply to the structure. All right. So as you go through, to me, the most important thing to understand and to think about, and it's kind of a state of mind because really it's code independent, whichever code you're using, they're all trying to check the failure modes. How can this structure fail? Right? So what are the ways in which it can fail? It could fail ending from tension or compression when it yields. If it's in tension, it could fracture. For compression, there's stability, right? This thing could buckle like this bridge here in New York did several years ago during construction. So if you know the failure modes, only one of these modes is going to control, because these failure modes, you may have a very high capacity for tension, but a very low capacity for compression. So obviously the compression one is what's controlled because of the lowest capacity. That's your controlling capacity in your capacity demand equation. So you have to figure out all the different failure modes. Whatever the least is becomes the capacity of that member, and we need to ensure that is greater than every demand. And that's as simple as what we're trying to do here with this process. Where can you get some of the information? Hopefully you'll have an opportunity to look in the AASHTO, or American Association of State Highway and Transportation Officials, AASHTO LRFD Bridge Design Specification. It's really, I call it the Bible. It's the main book that we have to use within our bridge world. This has all of our requirements. Like many of the codes that you may see, it's a two-column code. There's a left column and a right column, right? The left column are the requirements. As you read it, you will see you shall do this, you shall do that, and it's written in the requirements of the code. The right column is directly related to what is in the left column, and it's commentary. We recommend, or it's recommended that you do this, you should do this. And it gives you some, maybe historically we have done this, and it gives you some background and some more ideas. It gives you references to other research and places you can find information. to try to help inform your decision as to how you apply the code. And that's the way that works. For our competition and for this, typically there's 3 chapters of it that are important. Chapter 3 is all about the loads, applying loads, and how you apply loads in bridges. Chapter 4 is about analysis, the analysis of bridges and the different types of analysis that can be done and should be done. And finally, Chapter 6. This is the steel design or the steel capacity equations, where you can figure out how to design members for different failure modes, and you work your way through that. Now, the AASHTO and any code is not all-inclusive. It's often important that you have to go to other sources to fill in the gap, such as the AISC steel manual. Even though it's not specific to bridges, it's still very useful and has a lot of very good information that's worth dealing with and trying to capture. Another really important aspect to this, and I think will become important as you go through the process of doing this, everyone makes mistakes, and as you do this, you're going to make mistakes. Typically in school, as you do homework or do an assignment, the teacher, your professor, is the one that actually does the grading. But once you get a job in life, your peers become your graders, right? And so whenever I do a set of calculations, one of my coworkers will go through and check to make sure that I haven't made a mistake, right? The consequences of failures in structures is too great to not do something like this. And so there's a lot of ways you can do the quality control, quality assurance process. We have a link here, and you can look at that later. The Utah Department of Transportation has a very explicit method for doing it. It's pretty well done, and it's useful because as you go through and check it and understand that I need to make sure that this is correct and I don't have errors, you need to have a process for doing that. And I would recommend as a team that you all set up some idea for the process of doing this. And I would include that as part of your write-up, is this is how we're making sure that we don't have errors. We've gone through a very deliberate process to check the calculations. And it also means that as you do a set of calculations, you need to make them checkable. You need to write down the code reference. This is where I got this equation. This is how I'm doing it. All those kinds of information become very helpful and useful as you go through there. Some advice as far as writing it. Typically, assumptions are really the most important things, right? You're going to have, examples of your calculations as part of your appendices and things, but what are your assumptions? If somebody else comes up later on, again, your coworkers or your grader, somebody picks this report up, can they understand what you did? What are the assumptions you made with regard to the geometry, to the materials? What kind of materials are you planning to use, the loading, your design approach, your methodology? You need to make sure these are clearly spelled out within your report, so that as somebody coming along after you understands, oh, that's why they did this. This is how they got to this answer. They were assuming that. And that's an important aspect of it. Also, and maybe lastly on the report writing side of things, is presentation matters. What you see here is part of a proposal sheet that we use, but it has text, it has pictures, maybe some call-out boxes. The presentation of the report, while it's not explicitly graded as you go through here, the presentation does matter. It will matter to the judges. They will see the effort you put in there and understand that you're trying to tell a story. And in a set of calculations and in a design report, we often put pictures of the detail, put pictures of what we're trying to do, hand drawing showing this is the orientation of the forces, something like this, but something to explain what your ideas are. And oftentimes pictures and call-out boxes can catch the eye of the person checking it or reading it more than just straight text. Finally, I don't have a lot of time left in my portion here, but this is something that's important, has been important to me and been very useful. And since I have an opportunity to speak to this many young people, I did want to leave you with a quick idea here. Some people call this the Eisenhower matrix. He's attributed with kind of some of the original idea of it. But to me, it's really important to understand, and this goes for this report, this project, your goals in life, to anything you do. You always need to understand what's important in your life and what's unimportant, what is urgent and what is unurgent, right? So if it's important and urgent, you're going to do it. I need to eat, I need to sleep. These are urgent things, they're important. I get emails all the time. I do need to check them, and just got to get through that stuff. There's urgent but unimportant things, and, an example of that may be watching, the NBA finals here, right? They're only going to be on one night, and the next day it's just the replay of the news. So it's somewhat urgent, but relatively unimportant in the grand scheme of your life. You can do those things. They're necessary and they're fun, but do it in moderation. The really important part of this whole matrix, and the one I really want to point out, is the important but unurgent things. So there's always things in your life that you're going to realize, I really should do this. This is really important to me, but I don't have to do it right now. You have to prioritize and plan for those things. If you don't prioritize that aspect of your life, I would say any of the major successes that I've had, it's because I prioritized something that's important but wasn't urgent, and I got it done, and people said, wow, you did some really neat things. Well, it's because I made it a priority over a long period of time. Maybe writing this report is that, right? It's not urgent to start it initially, but if you wait till the last minute till it becomes urgent, you cannot do as good a job. Finally, the unimportant, unurgent things, you need to eliminate those and just make sure you have somebody who's accountable that try to keep those types of things out of your life. Hopefully it's helpful, not related to this exact topic, but I think it's something that's hopefully worth hearing there. So thank you very much for your time. I appreciate it, and want to pass it over to Christine to talk about analysis.
All right, so while Chris gets her screen set up, we'll just go ahead and give her an introduction. So Christine Freisinger is an associate principal at Wisjani Elsner Associates in the Chicago office, where she has worked as a structural engineer since 2004, primarily focusing on the investigation, evaluation, and repair of existing structures, with specific emphasis on unique structures, including the Gateway Arch, the United States Air Force Academy Cadet Chapel, Aloha Stadium, and the Duke University Chapel. Christine is a graduate of the Illinois Institute of Technology and the University of Minnesota. She is a past president of Structural Engineers Association of Illinois, or SEAOI, and a member of AISC's Task Committee 7 for Evaluation and Repair. In addition to her professional work, she has worked with local communities in Nicaragua through Engineers Without Borders. And during COVID, she spent time learning to make homemade pasta and play disc golf. So at this point, I'll pass it to Chris to talk about the analysis portion of the project.
Christy, thanks for that introduction, and I'm happy to be here today to help share some of my experiences so that the students can prepare a good report for their portion of the submittal. So as structural engineers, we often use software programs to efficiently analyze structures to confirm the design along the means of what Jason had been discussing. So for those analysis results to be useful, we need to make sure that we can describe our assumptions, inputs, and outputs to the rest of our team. And often this results in a deliverable in the form of a calculation package, which is a portion of what you'll be submitting with the bridge design. So as a basis for my portion of the presentation, I wanted to introduce you to a project that I worked on recently at WJE. And while the structure is not a bridge, it's an example of unique steel structure that required analytical analysis. So this photo here is the United States Air Force Academy Cadet Chapel, and it's located in Colorado Springs, Colorado, along the Rocky Mountains. The chapel was designed by Skidmore, Owings & Merrill and completed in 1962 and provides multiple worship areas for the Academy. Over time, the joints between the panels started to deteriorate, allowing water leakage into the chapel. And AECOM and WJA has been working with the Air Force Academy to solve this problem. So our first design proposed just to take away the water source. So after a good laugh, we moved on to our second design option, which was designing a new rain screen with aluminum metal panels and new detailing between the joints that could hopefully perform better over time. So this proposed system ended up adding about 25% more dead load to the structure. So the architectural side of our design team wanted to know, will the existing structural steel be able to support the additional proposed loads, and what magnitude of deflections should we design the joints for? So we can certainly build really cool and complex models in a variety of analytical software programs. They can check the numbers, they can get out deflections, and we can, tell the rest of the team the answers that we've received. And then if you're working in a team atmosphere, often the rest of the team says something like, "Are you sure? Did we have this analysis reviewed internally? And is the calculation package ready to go to the independent peer reviewer?" Which, as Jason mentioned, you often have peers or colleagues reviewing your work as parts of these design processes. So how can we take this really cool, complex model and distill the analysis down to a step-by-step process for another engineer to review, understand, and then discuss any conflicts in our base modeling assumptions, inputs, and outputs? Essentially, how can you convince the team that your analysis is sound? So before you start modeling, there's a few things you want to keep in mind. So as an analyst, it's your job to ensure that your mathematical model is realistic. So it's entirely possible that you've built a valid model that runs, but the model doesn't correctly represent the structural behavior that you were trying to model. So the model doesn't need to look like the structure exactly, but it has to behave like the structure. And oftentimes we're using post-analysis confirmation of the analysis results, and you're putting a lot of engineering judgment and critical thinking into looking at the results that your program is giving you and deciding if that's the behavior you think you would be getting in real life or not. So often a phrase to capture all of this that you may have heard already is garbage in and garbage out. So to convince yourself that the analysis is sound and then to document the analysis, you need to make sure you understand the basic behavior of the structure that you're looking at. And we often break down unique structures into simplified models when we get started. So for Cadet table, we can start with the tetrahedrons that form the structure. And if we tilt up just one of them, you could even just model one of these tetrahedrons, which is really just a 3D truss, to take a look at the local behavior. And then you could put a bunch of them together, and then you could analyze one bent of the tetrahedrons if you wanted to, and then replicate those bents out to get the entire structure. So now that you have a model that runs, what's the difference between design and analysis? Design is what Jason was talking about. It's, what does your structure or bridge look like? And then the analysis portion here is, what are the effects of the load on that structure? So how do you use your analytical model to calculate the demands on these members and get the deflections out? So as Christy mentioned, the analysis subcategory criteria includes a couple categories. And when you're looking to answer these subcategory criteria, you want to be thinking really about how is your model behaving and how are you verifying that behavior, because those are the categories that they're looking for. How are you confirming that your model is running accurately? So when you go through your model setup, a couple things to keep in mind when you get started are your overall model geometry. I would say that one tip is always to be checking your units. Usually these software programs can accept multiple units, and it's really easy to goof up a unit at the beginning and not understand the answers you're getting at the end. You also want to make sure that you're giving some thought to your member sizes and material properties, as those will be important to estimate deflections. And then give some thought to the behavior of your connections and restraints. You want to make sure you're providing enough restraint for the model to be stable, but an overly restrained model can give you poor results. As you head into taking a look at your load cases and your load combinations, you want to be a little bit diligent about this. So I often develop a matrix of loads and combinations in a simple Excel file before I get started. Sometimes if you elect to let the software program make the load combinations for you, there's often a lot of combinations, and it doesn't give you a good sense of which combinations may be controlling, especially if you're just looking at an envelope of the cases together. And then you'll go on to usually checking your capacities. So most software programs are a really powerful tool that can calculate the capacity of the members for you. But to do this, the software often starts by making assumptions, such as unbraced length or interaction of loads. So it's prudent to be aware of those assumptions and update them when required for your behavior. We also usually do hand checks of some of the highest stress members to confirm the software results. You can see in this overview of Cadet, we've got some members that are getting to have an interaction ratio of just about 1. So we would have taken the results of the analytical software and then also confirmed those by hand using the code checks to confirm what the model is outputting for us. And then when you're taking a look at deflections, again, you want to be really considering the effects of the restraints. So you probably noticed that some of the overviews of the model I showed previously had pin bases at the base of the tetrahedron vents. And in this view, we actually ended up modeling a lot of the concrete substructure. So depending on what kind of behavior you're looking to get out of your model, you may be updating the model with different variables. So in our case, we really wanted to make sure we had those deflections right. And we knew the substructure would be deflecting a little bit, so we wanted to capture that. Another thing to consider is the stability of your model. So many, but not all, modern commercial structural analysis programs are capable of accurately and directly modeling significant P big delta and P little delta second order effects. So you want to make sure you understand how your software program is handling those effects and what is, and just as importantly, what is not included in that analysis and how you're verifying that for the programs. A lot of the software programs being used have verification examples, so you may want to check out those examples to see how your software works and make sure that those assumptions and runs are appropriate for the design that you're working on. So as Jason touched on as well, there needs to be model verification completed. So this is often referred to as a QC/QA program. So a good program is a deliberate and systematic approach to reducing the risk of introducing errors and omissions into the design. So the designer, the person making the model, often performs the quality control of his or her own work by establishing procedures for self-checking the work for accuracy. And then the reviewer is practicing QA, and they're responsible for independently checking the work of the designer to assure the correctness and meeting the design requirements and expectations of the project. So it's usually a 2 or 3 step process. You're checking your own work, and then someone else on your team is checking that work and in more of a global view. And then in this case, the third reviewer is going to be the AISC team. So there's a lot of references that you can use for model verification, and some can be pretty simple. This is a list from the American Council of Engineering Companies as part of their casework. And it's just a very straightforward bulleted list on things to check in your analysis. You can also go to a more complicated checklist. So this checklist gives an example of some inputs, some modeling considerations, loads, and then also some post-analysis checks, which we had talked about at the beginning. Is your analysis giving you reasonable output, and is the behavior consistent with, what you're looking at in real life? And then as Jason mentioned, you can go to a really detailed procedure, which is what the Utah Department of Transportation has on their website. So there's a wide variety of things you can do to verify your model. When we're putting together model verification packages, we're usually looking at hand calculations that confirm the analysis input. So we're doing some quick hand checks to make sure that we've got all the loads in the model correctly. And then we're doing hand calculations to confirm the overall structural behavior. So a couple slides ago, you saw some overall wind analysis on the structure. And then your calculation submittal is really going to outline all of this together. So we often put it together kind of like a book, right? We've got a table of contents, then each of those chapters digs into a specific topic that you're looking to verify. So this lays everything out very clearly for the reviewer so they can follow your thought process and follow the path through your analysis. And you want to be really clear. I mean, Jason had also mentioned you want to mix and match text and photos. You kind of want to be as clear as you can possibly be to make it as easy for the reviewer as possible. So kind of with this analytical portion of it, you really want to keep in mind the garbage in, garbage out phrase. So your data going in, it could be good data, it could have some errors in it, and then through your modeling, maybe the program's making some assumptions that you don't realize. You want to be careful about all that because you really want quality input, you want a quality software program run, and then you want output that matches what you're looking for kind of in real life behavior of your bridge. So with that, I will pass it off to Leo.
All right, thanks, Chris, for talking about the analysis portion. And just a reminder to the audience real quick that there is the Q&A window. So you're welcome to ask questions at any time, and then we will share those with our speakers at the end. We'll answer those as time allows. So don't be afraid to use that throughout the presentation. So then at this point, I would like to introduce Leo Fernandez. And as a leader in Thornton Tomasetti's transportation practice, Leo Fernandez is involved in a wide variety of transportation infrastructure projects, including both new and existing structures. He has more than 23 years of structural engineering and project management experience in the design, analysis, rehabilitation, and inspection of roadway, transit, railway, and pedestrian bridges and various structures. During his career, Leo has built up a solid portfolio of transportation work for both public and private sector clients, primarily in the New York metro region. His credits include providing engineering services for the rehabilitation work at the Verrazano Narrows and Williamsburg bridges, repair work at the Henry Hudson and Tappan Zee bridges, and more recently, the award-winning rehabilitation of the High Bridge in Bronx, New York. Leo has experience with alternative project delivery methods, particularly design-build projects. He was also the project manager for the recently completed Sunnyside Yards master plan. So at this point, I will turn it over to Leo to talk about construction sequencing.
Thank you, Christy. All right. So now that you've gone through the design and analysis of your bridge, let's go into the construction sequencing. So before that, let's get started with a video. This is a bridge in Norway. This is the Randselva steel bridge, which shows the different construction phases, okay? It's a 3-minute video, and we're gonna walk through it. So one of the advantages of technology these days is that we can do some 4D visualization of what we're trying to build. So here, as you can see, this is a 4D visualization, starting off with showing the project site, understanding your constraints, figuring out where you're going to have your laydown area, where you situate your cranes. And then after that, understanding what can I do to build my bridge, but at the same time, satisfying the constraints that's out there. So in this bridge in particular, as you can see, it's probably in a protected area. So you cannot just do the construction all over. And so what the engineers designed here is a gantry system. This is what's shown in blue right now, where it's launched from the approaches of the bridge out to the piers that was already built prior to that, right? And this is quite ingenious, as you can see. It just slowly moves the gantry, and then from there you build your tower for the suspended part of the bridge. And once you reach the piers, you lift the gantry over, and then you situate it onto the pier, right? And then you just continue doing that until you launch the bridge continuously until you reach the other side, right? So this is a perfect tool that allows you to visualize each step of your bridge construction. And it also allows you to understand the feasibility of the different steps, or what you would call a constructability analysis. Can I do this? What can I do and what I cannot do, right? So as you can see now that the superstructure and substructure are set, then you could just work on the deck of the bridge. And that's it. So this is quite a nifty tool to be able to visualize your step-by-step construction procedure. Now, as Christy mentioned earlier, with the construction sequencing section of your report, we will look at your construction planning. What are the types of connections? What's the number of builders? What's the efficiency of your sequence? What's the potential challenges? And what's your total construction time, okay? So it all starts off with, as I mentioned before, understanding your constraints and your limitations. Once you figure out your constraints and your limitations, now you have to figure out what type of bridge am I going to build? Is it going to be an arch bridge, a truss bridge, a beam bridge, a tied arch bridge, a suspension bridge? For steel bridge competitions, they have been either the beam bridge type, the truss bridge type, or sometimes you even have the bowstring truss type of bridge, right? And so once you figure out exactly what type of bridge you're going to be building, then that's when you could start figuring out what type of connections you're going to have, a number of builders that you may have. In the real world, what we have to deal with are our stakeholders. You either have architects or public agencies that have a say in terms of how your bridge is going to look like. Here, in this theoretical steel bridge competition, really, it's your call to figure out what type of bridge you're going to build to satisfy those different requirements that are set in the rules, right? And so it helps for you to understand from your respective universities and schools what has been done before for your steel bridge competition, or even look to other schools as well. What worked and what didn't work for them. The examples that you're seeing right now are you have a truss bridge, you have a beam bridge, and that has a truss element in it, and you have a bowstring truss type of bridge on the top right. And so in terms of construction sequencing, what really is behind construction planning, especially in the real world, is what we call the critical path method, or CPM. This activity on arrow diagram boils it down to the basics of the critical path method. You have a start and you have a finish. On a global scale, you have the start of building your bridge, and finish is you're done with your bridge. And you can boil this down to the different subcategories or subtasks of building your bridge: installing the bottom truss, installing the a beam across, things like that. And so to go from start to finish, there's different tasks. You have A, B, C, D, and E. The numbers that you see between the different tasks, 5, 15, 6, 9, and 8, those are the durations. How long does it take to go from A to D, from B to D, from C to E, and to the finish? And so this is the gist of the critical path method. In the end, the analysis involves figuring out what's the most efficient way to go from the start to the finish, whether it's going through A, through B, or through C, right? And of course, there's different software that are available now in the market. So in the industry, what we call CPM scheduling is the critical path method schedule. And you have Primavera, you have Microsoft Project, you have other tools out there. You can even go as basic as using an Excel spreadsheet to do your CPM scheduling. And this is what we're going to look into in terms of your report, how you create your work breakdown structure or your subtasks to build your bridge. You start off with your substructure. From your substructure, you go to your superstructure. And then you boil that even further down into the different elements that needs to be connected. You figure out how long it'll take to install specific members of your bridge. And then also what types of connections you're going to use to be able to make it a more efficient construction. And so everyone in this call probably has been to IKEA before. This is actually an example of an IKEA furniture called Billy. And IKEA actually does a really good job visualizing the different step-by-step processes that you have to go through for this example to build this bookshelf, right? The Billy bookshelf. So as per the guidelines, this is what we're looking for from you as well. The challenge of this competition is that contrary to your normal steel bridge competition, you have to visualize things as opposed to having the go and green signal to fabricate things, right? So you have to visualize it and then create diagrams for it so that if you pass on this document to someone who's an engineer, not an engineer, they will also understand how to go from point A to point B. So keep that in mind. Good drawings, good graphics helps your report. And of course, construction innovation. This is an example of an innovative way during the construction process that the team members were able to span over the constraint. In this case, the blue part is your river, right? how can you pass on materials from one to the other? So they created this temporary gantry. So we're looking for innovations in terms of your constructability, but of course, innovations in terms of your design. What type of connections do you have? Is it going to be a pin connection? Is it going to be a bolt connection? Things like that. Anything that would make your bridge unique and a component that helps you build the bridge faster or make your bridge stronger for that matter. So we're looking for you to innovate in terms of these elements as well. And so in terms of construction innovation, once you introduce innovation into your design, it results into two main things: time and cost savings, which if you're in actual steel bridge competition will help you a lot, and of course, enhancement of the performance of your bridge in terms of its capability to carry the loads that are required. I'm going to show you a video. This is by Brookfield Properties. This is a project that Thorin Tomasetti was part of. It's called the Manhattan West Platform Program. This is in New York City, and this is along the west side of New York City. If you've been to New York, it's just west of Penn Station. It's over a rail yard. And so the constraint here is that we need to build what we call an overbuild deck, in other words, a glorified bridge over this active rail yard, which is served by Amtrak and Long Island Railroad. And so with this 4D visualization, we were able to figure out, okay, how can we do this? Of course, we're going to take advantage of the sides of the site, right? The adjacent properties. How can we take advantage of that? In this case, the idea was to build this temporary gantry. And in this case, this is a precast concrete type of structure, precast concrete segmental type of bridge. First is we installed all the temporary structures so that you're able to create this moving gantry along the rail yard. So here now, as you can see in yellow, this is the launching mechanism that will take one piece of the bridge to the gantry, and just like pieces of Lego, we move it to the other side, you pick up another, you move it to the other side, and these are put together using what you call tendons, so they're post-tensioned, and in compression, all the different segments are put together. And then once you put all these segments together on top of the bridge, now you have one span, and you just drop that down one after the other until you're able to complete what you call the deck overbuild on top of the rail yard. So this is one innovative way that we were able to come up with that helped us to build these bridges, this deck overbuild on top of the rail yard, maintain service for Amtrak and Long Island Railroad along the way, and of course achieve the goal towards the end. So this is what we're looking for, essentially, on a theoretical side in your end, once you figure out how to design and how to build your steel bridge. Great. And so with that, I'm going to pass it back on to Christy.
All right. Thanks, Leo. So at this point, I'd like to direct the audience back to the moderator window on your console. So if you made that presentation window full screen, you may need to escape out of that and get back to the main console. So at this time, we'd like to talk about AISC's partnership with NCSEA. So we are excited to announce that we are partnering this year with NCSEA, which is the National Council of Structural Engineers Associations. NCSEA includes 44 structural engineering associations that are located throughout the United States, representing the areas shown in green on this map. Their mission is to support practicing structural engineers to be highly qualified professionals and successful leaders. So what does this partnership mean for you? Well, it means that you will have the opportunity to get connected with a structural engineer in your area to provide mentorship and guidance for your team, which could be particularly helpful as you prepare your analysis report. We have developed a list of contacts with the help of NCSEA, and so you can visit this new page. It's aisc.org/SSBC-NCSDA. There's a full list there of the local contacts for each of the 44 member organizations. And so you can reach out to that point of contact in your area that's closest to you for more information and to get connected with them and have a conversation about how they could potentially mentor your team. And then we will also be posting a template to help get that conversation started. So I encourage you to check that out. And then these member organizations are excited to hear from you, and there's a variety of different ways that they can help you out. So at this point, I'd like to pass things over to Chris, who is a past president for SEAOI, which is the Structural Engineers Association of Illinois, to share about her experience involved in the organization.
Thanks, Christy. So as Christy mentioned, NCSEA is an organization of member organizations. So structural engineering associations are members of SEA, and then us as structural engineers are members of the state organization. So Christy mentioned that NCSEA has 44 members or structural engineering associations, and some of those states like California break out even further into a couple different regions. So hopefully you have an SEA either in your state or in a neighboring state that you can link up with. SEAOI, which is the Structural Engineers Association of Illinois, gave me opportunities to give back to my profession above and beyond what I would have been capable of doing on my own. So at the time I was in undergrad, IIT, the Illinois Institute of Technology, didn't have a student chapter yet. So I wasn't introduced to SEAOI until I started working. I was encouraged to attend SEAOI events by my mentor as a way to get to know fellow engineers within Chicago. And he noted that while we are not often working directly with other structural engineering companies on our projects, we can connect through our professional organizations and act together to advance our profession. Around 2008, I was at an SEAOI event and said to a fellow female, well, there are so few women in our corner of the industry, why don't we just know them all? And the two of us started the women's networking group within SEAOI, and this group has grown into a Women in Structural Engineering Committee, and that's referred to as WISE, and WISE has chapters across the United States. So I really enjoyed my time with SEAOI as a committee chair, and then ended up applying for the board of directors and eventually found myself on the executive track to become president, which wrapped up last year. So through my involvement, I was able to participate in the renewal of the structural engineering practice in 2019 for the state of Illinois, and that involved meetings with our Department of Professional Regulation and working with fellow professional groups, including AIA and ISPE, to align our professional acts. And I was also involved with the structural work group to introduce the long-awaited IBC-based Chicago Building Code. So while I've certainly enjoyed the benefits of SEAOI, there's plenty of benefits that your local organizations can provide you. And keep in mind that you don't have to have been graduated and have a full-time job to be a member. SEAOI has a couple student chapters affiliated with us, and I believe a lot of other states have that as well. So you can definitely get involved with your local SEAs, either by just reaching out to say hi or joining a committee or going to some events for networking or continuing education. It's been really helpful to me, and I know that the SEAs are, they've got a lot of good folks in them, and if you guys reach out for help on your projects, I'm sure we'll be able to find people that can help you out.
All right, thanks, Chris. So at this point, we will kind of go into a more general discussion with our speakers about what it's like to put together engineering reports and then how they handle that within their offices. So again, I'll just remind the audience that you can use that Q&A window to ask any of your own questions, and I will share those with our guest speakers. So Leo, I'd like to start with you. I'm curious, what does it look like to work on a large report with a team at your company? Like, how do you go about dividing up all the tasks amongst your team members, and how do you work on that as a group?
Sure. So in the company, before we start working on a large report, it helps to start with the most important step, which is understand what you are trying to deliver. So in our case, what's your scope of work? What is the report that we are delivering? And do we know what the different parts are that goes into this report, right? And so it involves understanding that there should be an outline, okay? So how do you divide the tasks? So even before you divide the tasks, normally there is what you call, for all intents and purposes, we're creating a technical report, right? You would have what you call a technical quarterback. And this is usually a senior engineer that has done this before. And so that senior engineer will be able to estimate the number of people that he or she needs to be able to complete this report. Not only understand how many people you need, the amount of resources, but also who are the right people that can work on this report. Once you've developed the team that will work on the large report, during our kickoff meeting, we understand the strengths and weaknesses of each members of the team, and then we assign specific tasks. If someone is good with graphics, that person is in charge with graphics. If someone is good with writing, usually there's more than one person because this is a report. As Jason and Chris detailed earlier, the QA/QC, or quality assurance, is of the utmost importance. So we make sure that one person checks the other in terms of the different sections of the report that they're writing. So, and then of course, we also schedule regular meetings leading up to the due date so that we can check on everyone. And of course, maintaining seamless and constant communication is key to be able to deliver a good report. And so for the most part, that's the gist of what we go through in our firm. Yeah.
Okay, great. And so kind of building off of that, Jason, can you maybe share some tips for working on a report with team members who are remote? So kind of building off of what Leo shared with working as a team, but then what do you do some of those people aren't in your office?
Yeah, no, and then that becomes even more topical today than maybe ever, since so many people are working remotely, and I assume that's going to happen at your school as you try to work through this as well. And the number one thing and the easiest thing is you've got to get a program that you can work on jointly, that you can have live editing, and that's the easiest and best way to do that. There's a couple of different softwares. You can get on Google Docs, and basically it has Word documents and Excel type files where you can go in there and multiple people can be in the file at the same time working on it. Because if you don't, you have a version control issue, right? I started working on the document and I'm trying to get towards the deadline, and I made some edits, but then somebody else made some edits, and now I've got to transfer mine to another, and you may miss somebody's copying that over. So it's generally best if you can work in one document, one location. Bluebeam is another program that we sometimes use, where you can get in there and everybody work together to provide comments to a PDF, and then have maybe just one person holding the master copy and doing the edits for you at the end. There are other ways of doing it, but finding a way that everybody is seeing the same program or seeing the same file, and making sure you don't have multiple files floating around on different computers, having them stored at one central location on maybe a central server or a central computer. That becomes a major part of working remotely is making sure that everybody's working on the latest version.
Okay, great. And then building off of that, Jason, when do you start writing a report for your project? Is it something that you work on along the way, or do you wait until all the analysis and design work is finished? Kind of what's your strategy?
Well, for something like this, especially when we know that we have a deadline, and Leo said it, right? You know that you've got to start an outline. So inevitably, you need to start building that outline and start thinking about what goes into it. Because as on this type of project and this type of thing, you have a limited number of pages, and you can't put everything in there. So you need to start prioritizing, the work you're doing and the steps you're taking to be what is going to ultimately need to be in the report. So setting up that outline, as Leo said, is going to be a first step, and you can do that right out the bat because you know what's going to be there. And then keeping in a matrix of decisions that you make is something we often do. So as decisions need to be made, we don't want to second guess ourselves and go back and rehash the same decisions. We'll make decisions, we'll document it in a little decision matrix and say, hey, this decision is what we're going with, and move forward. That becomes an assumption, and it goes into your write-up in the assumptions here. We're assuming this is our decision, we're going to move forward with it. So documenting those things, getting them down on paper, much of the report can already be completed, and then at the end, as you're trying to rush to finish up any project, because it's always a push at the end, you're just dumping in the results. You're doing the quality control. You're making sure that you've got all the right pictures and figures and the headers and all the other proofreading and stuff. But going through it systematically and getting a jump on it at the beginning, it shows a better product, and you end up with a better product at the end of this.
Okay, and thinking about the final product, Leo had touched a little bit about the review process and making sure things are technically correct. So, Leo, can you talk a little bit more, give a little more detail about, what your internal review process looks like for things like reports and proposals?
Of course. At Thornton Tomasetti, we have a QA/QC manual, and we have people that are assigned to each office that one of their main tasks on a monthly basis is to make sure that QA/QC, or quality control and assurance, is implemented in all the projects, and within those projects, all the deliverables that are produced, and some of them are reports, right? The main thing to remember with the review process, if possible, you need to assign what you call an independent reviewer or an independent review team to give you a fresh set of second eyes. Of course, that independent reviewer also should have a copy of your scope of work. In this case, you're going to have the AASHTO guidelines. That independent reviewer would understand the rules and the guidelines, and then share their fresh set of eyes once a progress set of your report is ready for review. Why a fresh set of eyes? Because if you have someone within the team review it, which is fine as well, you could check each other, you still get a better feedback or a more comprehensive feedback when it's someone experienced that's looking at your deliverable or your report for the first time. So if that's possible, I suggest an independent reviewer. However, if that's not possible, then assign it to someone within the team that was not part of developing a specific section of your report. For proposals, it's a little bit more involved because there are several stakeholders and parties that are involved. We actually color code our QA/QC review process. You have a pink team review, you have a red team review, you have a gold team review. All of these are actually available online if you want to learn more about it. But essentially what it is that as you get closer to your due date, the review becomes more and more intense. In other words, you stay in the office until midnight because there's a lot more people involved reviewing it, and you have to address all these comments. Yeah, I think Chris wants to add something.
Yeah, exactly what you were just talking about there, Leo. Like one of the things that often gets overlooked on the internal review process is giving that reviewer enough time to do an adequate review and then leaving yourself enough time before the deadline to pick up all the comments. So as you're going forth and setting your schedule for everything leading up to your deadline, you want to build in that review time at the end. So you have time for the reviewers and you also have time to pick up those comments and then let the reviewer review any of that stuff one more time if the initial comments were substantial.
Yeah, good point. And then flipping roles a little bit, and maybe Leo and or Chris can answer this, but when you are the reviewer looking at a colleague's technical report, what are some of the things that you specifically look for when you're in that role? So we'll start with Leo.
Okay, what I'm looking for when I'm reviewing a report, it needs to be straightforward and clear. One thing that I learned when I was in school is that for a moment there's still this air of trying to impress my professor. And so I was always trying to go for these words that are so highfalutin And working in the industry, try to avoid that. Avoid using the word utilize when you can say use, things like that. And then try to not ramble. Go straight to the point with less words, right? So that's what I'm looking for, clarity and concise delivery of the message. And of course, another is a very organized and thought through report, including specific references on codes if you're using codes. I'm looking for the references to be clearly noted adjacent to the calculation or to the references.
Yeah, I'll just add to that, adding bullet points in there, putting things in lists and bulleted items is a way to make, for me, myself, I like to do that because that's very clear, it's concise, and you don't end up, as you said, don't ramble on too much, Leo. I think that's the important part of technical writing, is to be technically correct. You just need to make sure it is correct and concise. So.
Okay, great. Chris, going back to you, what do you find to be the hardest part of the hardest section of a report to write? So where do you typically get stuck, and then how do you overcome that?
So sometimes the hardest part of the report is actually just getting started. So if you're finding yourself kind of just staring at a blank page, I would go to what Jason and Leo had both referenced earlier, which is starting a bulleted outline and then fleshing it out from there. Another place I sometimes start is the end. So if you write the end first, you know what the end of your report is going to say. It's like your bridge is adequate and it's meeting all the deflection requirements. Then you can sort of start leading yourself back through the report saying, well, how did I decide that the bridge was adequate? How did I decide my deflections were okay? And start breaking it up into smaller chunks and just kind of force yourself to just start writing something for 10 minutes. And I usually find that if I just force myself to start it and actually buckle down and do it, then I kind of get into a groove and can keep going that way.
Can I add one other thing there for you, Chris? I like what you said about that. One other thing a professor once told me is put in your graphics. If you have charts, graphics, or pictures that you want to use, put those into the presentation, and then explain the graphic. And before long, you've kind of, or either outline it in the present PowerPoint. Like this is the topics as a visual way. 'Cause a lot of engineers are visual. Maybe you visualize it better that way, and then explain it. Is another way to kind of help you through if you're stuck.
Those are great tips. Hopefully people find those helpful. Chris, are there any resources that have been helpful for you as you've developed your own personal writing skills, kind of from a general perspective? Do you just learn by experience, or have you intentionally seeked out help from a mentor or a writing workshop or something like that?
Yeah, so I think one of the ways that I improved my writing and my calculations was looking at examples that other people had provided me. So if you have a means to find things, within your university, or now a lot of stuff's actually posted on the internet. So if you could find actual bridge reports or bridge calculation sets, having those type of examples will be really helpful. I have taken some writing workshops through the Structural Engineers Association of Illinois. So your local SEAs or the national NC SEA may have workshops that are available to you, and often those come at really discounted prices for students. So those could be an option too. I was fortunate enough to have a mentor who's a really good writer. So the first 3 to 5 years of my career was really focused on how to get those calcs really buttoned up and as clean as possible, and really get my writing down to the essential, concise words to convey the message across really clearly. So I think the more reports you can review from other people and the more calculations you can review from others, you'll start to see that calculations look the same. If they're done correctly and properly, they all sort of have the same rhyme and reason to them. And you'll start to see that the more that you look at them.
Okay, and then building upon that learning lessons and figuring out your own skills, Leo, do you have is there maybe a tough lesson that you've learned in your own career while developing your own technical writing skills?
Oh, yes. I think Jason touched on this earlier. Procrastination, yes. And it is, I think we've been guilty of that even when we were in school, and I was still guilty of it in the real world and the industry. Try to avoid procrastination as best as you can, because as Jason mentioned earlier, before you know it, you originally had 3 weeks to do the report, and then you felt that you had enough time, and next thing you know, you only have 2 days. And you end up spending 2 all-nighters to do it. Even though you were able to do it or produce a good report, you probably could have done better if you started it 3 weeks ago. And so I've been better these days after several lessons learned in different deliverables that I've been through. The challenge here also is that it's not just on you, right? As I mentioned earlier, you're part of a big team. And so one of the biggest lessons learned is to be a good project manager, to be able to, rope in your entire team and get them riled up and say, okay, here's the outline, here are the responsibilities. I need this from you by this day, by this day, by this day, right? It's no different than the professor saying, I need you to submit this to me in a week or so, right? However, in the real world, because you're not being graded by a professor, it is on each person to have the integrity and the sense to actually say, I have too much on my plate. I cannot give this to you today. Let me give it to you tomorrow. So it's a lot about time management. That's one of the biggest lessons that I've learned along the way. I've been better at it these days, but it took some time, to be honest. Yeah.
And kind of a lesson that I've learned, I was going to say a lesson that I've learned was I used to try to do all my calculation packages correctly the first time, and they were really a mess. And I think about 3 years into my career, I looked up at my office mate with a stack of papers an inch thick, and I said, well, these are all done. Now I just have to redo them all to something that someone can check. So I think, taking care when you're doing your calculations to know when something's actually getting too messy and it's time to decide that piece of paper is now a back of the envelope check, and then start again on a process, a fresh piece of paper that a reviewer can look at, is going to be helpful. You'll feel like you're taking more time, but the reviewer will be able to be more efficient and more, they'll have a better chance of catching any mistakes or errors in your analysis. And eventually over time, you'll get to a point where maybe those first set of calcs can be developed into your final set of calcs once you have a little bit more practice at it.
All right, well, great. Thanks for sharing your own personal experiences for others to learn from. So at this point, we'll kind of go into our kind of open Q&A. So again, the audience can submit their own questions, and I will share them with our speakers. So the first question that we have is probably for all 3 of you, and that's just, can you share what structural analysis software do you most commonly use in your careers, and what do you like and dislike about those different platforms?
Well, I'll jump in here real quick. Sorry. I'll start you off real quick on that. So on the bridge side of things, there's a lot of different analysis software and different design software. So on the design side, for typical bridges, we'll see BRR or MDX or a couple of those. There's a few others. Fortunately or unfortunately, depending on how you want to look at it, you're most likely designing a truss or an arch or something like this for this competition. And there's generally not a lot of software specific to those bridge types because they're uncommon bridge types. So the design side will most likely be on you. On the analysis side then is what kind of general analysis programs. And there are a variety. We tend to use Midas, but there's SAP, there's CSI Bridge, LARSA, and several others. If you're in an academic setting, you could use ANSYS or Abacus or any of the other general finite element. The detriment to those for our applications in the bridge world is the general finite element programs don't have live load generation. So we have moving vehicles, a truck moving around a bridge, and the Midas, CSI Bridge, and some of those do a much better job of making that easy for you and automating some of that load generation, different combinations. So that would be what my experience is. And so for you on this, this particular project is more of a static load. Really, any of the software that your university has available on the computers would probably work. And Chris, I'm sorry if I interrupted you.
No, I mean, just kind of building off what you said, at WJE, we're often using SAP, and that's mostly because it provides us a really wide range of analytical modeling techniques. So what I often suggest to associates when they start off with us is to learn SAP, because for our line of work, it's the program that's going to give us the most, the widest range of possibilities in our analytical software. And then I want the associates to start using it when they start at WJE, because you can't get to those tough analysis solutions if you don't know how to use a program. So I would say, you really want to use a program that you're comfortable using, and once you really know how to put together a model and verify it, the program that you're using sometimes becomes a little irrelevant, right? Like, I know SAP pretty well. It would take a little bit of user interface for me to learn a different program, but I'm still going to be going through the same process of developing my model, putting in my loads, getting my outputs, and then verifying that model. So that process is the same no matter what analytical software you use. So I would say use something that's available to you, that you might even be familiar with, and you just have to know the limits of that software.
Okay. Next question is for Leo. And so that someone was asking for clarification on what was built on top of the Manhattan Bridge project.
I have to jump off in a couple of minutes because I have to prepare for another presentation. But Christy, thank you for this invitation, because it's been a great experience working with you, and hopefully the students are able to gain some useful insights in this presentation. To answer that question, okay, yes, we built skyscrapers on top of the Manhattan Bridge project. However, it didn't. The foundation of the skyscrapers didn't directly sit on the bridges that we built. What happened was you have it pierced through it, so the load path doesn't directly sit on the bridge, but it goes directly down to the bedrock underneath it in some parts. It's not shown there because we just showed you the building of the overbuild, but in some parts there were actually mega columns that pierced through where we're allowed in between the railroad tracks. So that answers that question. Thank you, Christy.
Yes, thank you, Leo. Let's see, the next question, person says, I'm often overwhelmed with various tasks at school. So what is some advice that you have on managing and completing all the tasks? So I'm sure you as practicing engineers are often balancing several projects at one time. You don't necessarily get the opportunity to only focus on one for an extended period of time. So what's some advice that you can share for mitigating that situation?
Well, this is Jason. So I think a lot of that, in my view, starts with realistic time estimation. So in my past and other people I see that tend to struggle, oftentimes are unrealistic on their estimation of how long something will take. I'm going to work on this and I'll be done with this in 2 hours with this task. When I look at it and go, that's going to take them the rest of the day. And they're like, oh, no, I'll have this done in 2 hours and I'm going to do this and I'm going to do that. So the first thing is you have to be realistic with yourself and start recognizing how long a task is going to take. And sometimes it's even being overly conservative. The next thing is, if you think it's going to take 2 hours, go ahead and allocate yourself 3 hours in your day, and don't fill up that extra hour with a bunch of other things, because inevitably you get overwhelmed in the fact that you have overfilled your schedule and you start getting behind and you can't catch back up. Then the other thing is prioritization, right? I think making sure that you prioritize. And I think one of the things that's really hard in today's age, where we have cell phones and everything else that's always competing for our attention, if you really need to get things done, you have to focus. You have to really focus on your tasks. And so there are times when I'll go through, I will turn off my email, shut down the program so it doesn't ding me every 5 minutes that I got a new email, because you take my phone and turn it on silent or turn it off so that it doesn't ding me that I have another text message. Because any time that you're really needing to get something, whether it's writing or focus on your analysis or something that you've got to get your mind into, it takes several minutes to get into that problem and really focus. But it only takes a moment for you to snap out of it, because I'm chasing this another shiny object. And then now I've got to refocus. It takes me 5 minutes to get back into the problem and remember where I was at. And then the next shiny object pops up. And so you sometimes have to say, I'm going to set aside 1 hour. I know my emails are important. I know that I need to answer the text messages from other things, but I've got to just set that aside, and I'm going to focus on this task for an hour. And you can be super productive in that time frame if you'll set it aside and just focus on that for that time and not let the distractions keep pulling you out of your focus. And that's a really hard thing in today's day and age, in the way that electronics and everything are competing for our attention. Sometimes we have to shut those off in order to be hyper-focused and hyper-productive. So a couple of things there.
Yeah, and kind of building on what Jason said, those were all really good tips. I think, one of the things Jason mentioned is like overestimating how long it may take you to do something. And with that, you also want to make sure that you've got time in those tasks to get your task reviewed and then pick up any changes that the reviewer has. Often those kind of items aren't included when you're setting up your daily or your weekly schedule. And I think that's sometimes how people get overwhelmed, is something either takes longer than they anticipated, or they have to redo part of it because an assumption was incorrect or the answer didn't work out the way that the reviewer expected it to.
Okay, great. Thanks for those answers. Chris, and we have a question for you about, when you're looking at the output from an analysis model, sometimes these programs generate pages and pages and pages of data. So how do you use that in the best way possible when you're putting together your calculation package? Do you just print it all out and put it in an appendix, or do you have some other strategies?
Yeah, so I do some peer reviewing in Chicago here, and that's like the dreaded peer review, is when you get someone's like pages and pages of input and output tables that make it really hard to check. So I would say that backup data is definitely helpful for documenting your model, because it's the only output that you have that kind of describes where all your nodes are and where all your loads are put and everything. I think everybody that's been a presenter here today has been a pretty big fan of including pictures in your calculation packages and your reports. So any sort of like graphical screenshots you can include of your model, and you could even annotate those. I often print them out and annotate them by hand, but I've gotten really good at Bluebeam the last 6 months. So maybe now I might be printing them to PDF or grabbing screenshots and then annotating them in Bluebeam. I think any sort of picture representation of your model is much easier for a reviewer to go through and understand than the tables and tables of input and output.
Okay, great. So thanks for that insight. Looks like that wraps up the questions that have come in. So thank you for taking the time to answer those. And so before we wrap up, I do have a few more brief announcements to share with our audience. First, I want to let you know that our next webinar for students will take place on Wednesday, October 14th at 4:00 p.m. Central. We will discuss this year's Student Steel Bridge competition in more detail. So that will include the different competition options as well as our time frame for making decisions about the in-person event. So there will be plenty of time during that webinar to ask questions, and we will provide those answers to you before the pre-registration deadline of October 30th. You can find the link to add the event to your calendar at aisc.org/SSBC. And again, this is a free webinar for all students. We are also excited to let you know that we are partnering with Repicture again this fall. So Repicture is a virtual community where people can learn about engineering and STEM projects and careers. So you will have the opportunity to research and write about projects constructed in structural steel for a chance to win awards and prizes. The projects will be reviewed by AISC staff, and it's a great chance to build your resume. There are 2 rounds of competition this fall, one that actually opened today and closes at the end of October, and the other that closes at the end of November. So you can check out aisb.org/repicture for more information about the program and how to get started. And as always, we encourage you to follow AISC on any and all of these social media platforms. It's a great way to get information about upcoming events, learn about new advancements in the industry, and hear about cool projects. We have a unique hashtag just for SSBC this year, and that's SteelBridge 2021. So feel free to use that in your own posts that you want to share with us. And then as this webinar concludes, there will be a short survey that will pop up on your screen. We ask that you please help us out by completing that survey. We greatly appreciate your feedback, and we'll take that into consideration for future events. So before we wrap up, I would like to give one more big special thank you to our speakers, Jason Stitt, Chris Freisinger, and Leo Fernandez. We really appreciate you joining us and providing your insight. So thank you again, everyone, for attending today's webinar, and have a great afternoon.